So once again, just doing the video from my couch, trying to teach you just how to do inequalities. So here's the symbols that we kind of introduced yesterday. We've talked about quite a bit. The first one is a less than symbol. So you would read it less than, right? The arrow is pointing to the numbers that are in the least direction, right? The lowest numbers are to the left. So then a greater than symbol is pointing to the numbers that are biggest to the right. Okay, it's like a little arrow. Think about the arrow shooting it. Now remember, the line tells you it can be equal to. It's like half of an equal sign. So less than or equal to means that it could be less than the number or it could be equal to it, right? And then greater than means it could be bigger than the number or equal to it. So if I look at the first one, so it says Caleb has at least $5. So at least tells me I have $5 or more. At least is telling me I have $5 or more. So X is going to be either bigger, greater than, or equal to 5. Okay, now you're going to look that I now have to graph it on a number line. Okay, so first of all, you have to understand less than or greater than, you're just having an open dot. It doesn't mean including that number. Okay, if I have a less than or equal to or greater than or equal to, it's a closed dot because it's including that number. It's including the 5. So X is greater than or equal to 5. Therefore, X, I put the dot at 5, filled in, and then I make it bigger than, going to the right, right? Look at the arrow. If you look at the arrow, it's pointing to the right. Okay, that tells you which way your line should go. Okay, so Tariq, whatever, weird, okay, has more than $5. So he can't have just $5, it has to be more. Now you're gonna see I made a mistake and I accidentally included it, but it should be an open dot going to the right because it's greater than $5. Okay, so let's look at the next one. Vanessa has at most $5. So the word at most means I could include the $5. She has either $5 or less. So X is less than or equal to 5. So it's going to be a closed dot on 5. But look where my arrow is pointing. It's pointing to the left. So it's including all of those numbers to the left of 5 or including 5. Okay. Here's a good one. Lee Chin. Okay. Lee Chin has less than $5. So X, easy one, less than 5. So ask yourself, is it a closed dot or open dot? Well, I just showed you it's an open dot because it's not including 5. So it's going X is then 5 is going less than, it's going to the left. It's going to the left. Okay. Let's look at these examples. Kelly works for Quick Oil Change. So if customers have to wait longer than 20 minutes for the oil change, the company does not charge them for their service. That must be sweet. The fastest oil change that Kelly has ever done is 6 minutes. Show the possible customer wait times in which the company charges the customer. So it's no longer than 20 minutes for the wait time. So it can include 20 minutes because it's either longer than 20 minutes. So it can include it. So I want to show you the possible wait times, right? It's any number that is from X has to be less than, but it can also be equal to $20. 20, sorry, not equal to. Okay. So if you look at that, I'm thinking, yep, there I go. I fixed it, right? Less than or equal to 20, not $20, 20 minutes. So then it's any number from 20 all the way over less than 20 minutes. Look at my arrow and look which way my arrow on the number line is going. So let's to the next one. This is a weird name, right? Gurnaz, right? Gurnaz has been mowing lawns to save money for a concert. Gurnaz will need to work for at least 6 hours to save enough money, but he must work fewer than 16 hours each week. So I want to write an inequality to show how much he has to be able to work, but it has to be less than 16 hours. So fewer than tells me something. Okay? Fewer than 16 hours. So at least 6 to save enough money, but it's fewer than 16 hours. Okay. So I'm thinking right now, okay, how would I write this inequality? Well, fewer than 16 hours. So X, maybe that fewer than 16 hours a week. I know I keep saying it, but remember it's important. Okay. So X is less than 16. It can't be including 16 because it has to be fewer than 16. I could work 15.99999 and it's okay. So I have an open dot because it's just less than 16. And then my arrow is going to the left. Something happened, not sure. All right, so let's look at some of these examples. Like I would usually just have you do these in class, but I want to make sure you're really understanding and knowing how to do these. So you know I have crazy quarantine here. That's why I'm wearing a hat. Sorry. Okay, so let's look. Got sidetracked. So write an inequality to represent each situation. But then I need to graph the inequality. So Braylon has at most 2 meters above sea level. So at most means it could be including 2. So X is less than or equal to 2. So I have a closed dot on 2 going to the left. Look at my arrow. All right, let's look at Edith. Edith must read for a minimum of 20 minutes. Must read. Okay, so minimum tells me I have to at least read 20 minutes, but it could also be bigger. So X is greater than 20 or equal to. So I would put my dot minimum, right? Minimum tells me that I could include 20 because it's a minimum. You can include 20, but it needs to at least be bigger. So I have a closed dot on 20, and then it's all of my minutes going to the right of 20 because it's X is greater than or equal to 20. All right, look at Travis. Okay, Travis is gonna milk his cows in the morning. So I want you to try Travis's problem on your own. Okay, see if you can do it on your own. I think you can do it. Okay, try it, do it on your own. Okay, let's look at Rita. So Rita's tricked me at first. It really did. I had to think about it for a second because there's quite a few numbers. So Rita can make 8 cakes for a bakery each day. So far, she has orders more than 32 cakes. Right now, Rita needs more than 4 days to make all 32 cakes. Okay, so I'm thinking, like right now, it's got me confused. I don't really care that it's 8 cakes a day. Because if you see, it says Rita needs more than 4 days to make all 32 cakes. Okay, that's why I'm really underlining it right there. That's the most important part of it. Because it's X 4 days, right? X is greater than or equal to 4. Now I'm thinking to myself, okay, more than, I made a mistake. Okay, it can't be including the 4 because it needs more than 4 days. So I'm going to go back, I'm going to erase it because I'm thinking like, wait a minute, I think I just screwed up. Okay, so, yep, look at my eraser tool, messed up. Okay, X is greater than 4. That's it, because it's more than 4 days. I need more than 4 days to do it. Not 4 days or more, for more than 4 days. So I have an open dot on 4 going to the right. Now look at number 5. Here's Rita again. I want you to try this one on your own. I'm not going to do it for you, okay? But look at the word fewer than, okay? Fewer. So I want you to make sure you understand that word because it's going to help you solve it. All right, let's look at these. These are extension ones. I'm going to do, I think I did 2 with you. I'm not really sure. So Casey has been mowing lawns to save up money for a concert. Sounds pretty fun right now. Expect I'm stuck at home. He earns $15 per hour and needs at least $90 to go to the concert. So I want to know how many hours he should mow. So I took 90 divided by 15 to figure out how many hours that is. So 6 times 15 gives me 90. 90 minus 90 is 0. So X because the concert's going to be at least $90 to go. At least. So it's either going to be X is greater than or equal to my 6 hours to work, or Casey's 6 hours to work. So I have a closed dot on the 6, and then it's greater than, so it's going to the right because it's any number of hours 6 or greater. So it's going to the right. Okay. Let's look at Rachel. So Rachel makes 8 cakes a day. We already learned that, right? But now it's not. It's not whatever her name was. I forget. Brain fart. Okay, so she has orders that are more than 32 cakes. It says, how many days will it take her to complete the orders? Well, there we go again, 8 cakes a day. So X is greater than 4, kind of like the problem from before. So I have an open dot on 4, and then it's 4 days or more. So it's my arrow's going to the right. All right, let's look at Ranger. So Ranger saves $70 each week. Okay. He needs to save at least $2,800 to go on that favorite trip he wants to go to Europe. I want to go to Europe right now. Don't do it. Okay. How many weeks will he need to save? So I need to figure out how much he makes, how many weeks that is. So I take the $2,800 divided by my $70 per week. Well, I'm thinking, okay, 70 can't go into 28. Nope. Okay. But can 70 go into 280? Yeah. Right? 4 times. And then I subtract 280 and I get 0. And then I bring down my 0, and you put a 0 up there, and you subtract 0 from 0 and you get 0, right? Easy. Okay. So 40 hours. So we at least need to work 40 hours. At least. So it's X is greater than or equal to 40. Because I need to at least make the $40 per hour. So I have a closed dot on 40. And then he could work any more than 40 weeks to save his money. So it's going to the right. Okay. I want you to try number 9 on your own. Okay. Try this one on your own. It says Claire is less than $75, but she wants to buy 3 pairs of shoes. So what price could she afford for each shoe? Maybe divide. I would divide. Okay, here's the gym, right? $25 per month plus the 4 extra to swim in the pool. Okay, think about adding those together. Okay, so here's your problem set, right? You're gonna send this to me. This is what you're sending today, right? This page. So send a picture of to me of the problem set. PS means problem set. Okay, so you have 1, 2, 3, 4, 5, and 6 questions that you need to do. But if you look at the directions, I bet some of you will mess this up. Don't do it. You need to write the inequality just like we've been doing the whole lesson, and then you need to graph it on the number line. Think about the key words, okay? Key words, okay? If you need to go back, I would go back and pause the video after each question. Just pause it, see what you need to do, go back, rewind it. That's the greatest thing about this. You don't have to be like, wait, Mr. Medford, what did you just say? Oh, wait, I can put you on repeat. Do that. Put me on repeat. Listen to me all day. That's weird. Don't do that. But repeat myself. Let myself repeat whatever you want to say. Okay. And then that will help you while you're doing the lesson. All right. Hopefully you're having a great time. If you look, I'm sitting on my comfy couch teaching you smart kiddos how to do math. See ya.